All right, I want to do an example that can cause a lot of elaborate discussions in physics courses, and you'll see a lot of interesting discussions in the various textbooks. But I just want to talk about it briefly, and it's this idea of causality. And all we need to say about causality is if event A causes B, then B happened after A. That's what causality means. And so if we have two events where one causes the other, what should happen is that in every reference frame, that should be true. Okay, if you have two events that are causally related, then the order of events will be preserved in all reference frames. It must be preserved in all reference frames. Otherwise, something is wrong with our physics. And there's no proof of that other than we're going by experience. Okay. So I want to do an example, and then I'll talk a little bit about it. And I have the example that you see on the screen there. Suppose we send a wave or throw a ball between 2 points A and B. And I'm just going to focus on throwing a ball between these 2 points. Okay? And let's say the distance between the 2 points is D. And let's say the speed of the ball is C prime. So the time it takes for the ball to go from A to B which is T sub B minus T sub A, is the distance over the time, D over C prime. So that's the amount of time it takes for this to occur. And the ball doesn't get to B unless person A throws it. Or if someone's sending a wave, it could be any kind of wave. It could be a mechanical wave. It doesn't have to be a light wave. The amount of time it would take for the wave to go from A to B is given by this time. And of course, this would represent the speed of if it was a mechanical wave, like a wave on a water, this would be the speed of the wave. In this case, though, we keep talking about us throwing a ball. So the cause is here, the effect is here. What if an observer goes by us and moves with speed v relative to us? So let's say we have a rocket with an observer on it checking out the events, and the rocket's going with speed v to the right. What time interval does the person in the rocket observe? Well, the time interval, using the Lorentz transformation, TAB prime is equal to gamma times delta TAB, which is what we calculated, minus V over C squared times the separation between the two events. Well, the separation between the two events is D. And then this time TAB is D over C prime. So the question is it possible for us to observe, or is it possible, for this person to observe B happen before A? What would it mean if event B happened before A according to this observer? That would mean that the term on the right here has to be greater than the term on the left. In order for this term to be 0, in other words, what if So this means that d over c prime has to be less than v over c squared d. And I can cancel out the d's, and then I can say that this gives us 1 over c prime is less than v over c squared. And then bringing the c squared up here, I get v is greater than c squared, over c prime. So by rearranging this, I guess v is greater than c squared over c prime. Now, if the denominator were equal to the speed of light, then v would be equal to c. But we want v to be greater than c over c prime. That must mean, this implies that c prime is bigger than c. So that means that the object that's thrown from A to B, or if we sent away from A to B, has to have a speed greater than the speed of light. Of course, the speed of light is the limiting speed. And so this is not going to happen because these two events are causally related. Now, another example I can give is suppose I have, again, between points A and B, and let's say I have a string between points A and B. So here's A, here's B, and I jiggle point A up and down. So I have a string, and I jiggle point A up and down so that a wave ends up traveling from A to B. The distance between these 2 points, again, we'll call D. The time it takes for the wave to get from here to here is going to be d over whatever the speed of the wave is. By the time in the time it takes the wave to get here, then this point will start to oscillate. So it takes this much time for point B to receive the information from point A for point B to start oscillating up and down. In fact, two events that are causally related to each other, if the information is transmitted between them with a speed of v less than c. For the two events to be causally related, there's got to be information connecting the two events that travels at a speed less than c. Otherwise, we can't say they're causally related.